Okay, this video is going to be all about unit number 4, which was our conic sections unit. So if you want to get out your stuff from circles, ellipses, hyperbolas, and parabolas, that might be good. So let's start with number 40. So number 40 is asking us to write an equation in standard form. So I'm going to use completing the square to help me do that. So let me start by getting all of my x's together, which that's my only one. And then I'm going to get my y's together, and because I have this 8y term right here, I'm going to leave a little bit of space. And then I'm going to move my 180 over to the other side. When I do that, it will become a positive 180 over there. Okay, so I'm going to keep my x squared the way that it is, and I'm going to use completing the square to help me turn this into where I can find the center of that. So to do that, I'm going to take half of my middle term right here, including the sign. So that will give me a minus 4. And negative 4 squared is going to give me 16. And if I add 16 to one side, I have to add 16 to the other side. And so that's going to give me 196 over here. And that right there is our standard form of our equation for a circle. So I would highly recommend that you go back and look over all of your standard forms of your equations. Okay. All right, on 41, let me go ahead and write down that standard form of the equation because I'm going to need it for this question. For a circle, looks like this, where H and K are our center points. So here's H and K right here, and R is my radius. So on this one, they're just asking me to plug in. Notice it's going to be the opposite sign, and opposite sign with Y. And then I'm going to square my radius, which gives me 64. And so there's my circle in standard form. Put that away. There we go. Okay, on 42, it's asking me now to work with our standard form of an ellipse. Let me write down that equation. Here's my formula for the standard form of an ellipse that I'm going to be plugging into. Still, I have a center here at H and K. And then notice that A is going to move back and forth. So A is going to be the bigger one on an ellipse. A is always the bigger one. All right, so let me start by just drawing a little picture of what we have here. So I've got my center point at 3, -5. And then I've got a vertex at -7, -5. So 1, 2, 3, 4, 5, 6, -7, -5. So there's a vertex right there. So this being my center point, I'm going to note that this is 10 apart right there from 3 to -7. And then I've got a focus at 3 plus, and really plus and minus, since we're going to go in both directions. So 3 plus and minus the square root of 19. So I'm going to say the square root of 19 is 4. So 1, 2, 3, 4, and a little bit more. So I've got one focus here. And that right there is a distance of the square root of 19. But what that's telling me is that my x-axis is going to be my major axis, or my bigger one. So let's start plugging in some stuff that we know here. I know H is 3. And I know that K is -5, so I'm going to make that a +5. And an ellipse is always equal to 1. Okay, let's see here. I also know the distance to a vertex right here is 10. So that's going to be my number that's underneath x, since I'm going left and right 10. So 10 squared gives me 100. So I'm going to go ahead and plug that in. And then this right here is giving me my C value. So I know that C is 19, and I know for an ellipse that C squared is equal to A squared minus B squared. All right, so C squared is going to be 19, and I know A squared is 100 minus B squared. So 19 minus 100 gives me -81. Is equal to -b squared. And so I know that b squared is equal to 81, which is really what I need. I don't need b, I need b squared. And so I'm going to go ahead and put my 81 underneath y. And there's my equation for that ellipse. those puzzle problems, always a good thing to start by drawing what you have. So we knew that this ellipse was going to be bigger going left and right because my focus, one of my foci, or both of my foci, were on that left and right, or that x-axis. Okay, with 43 I'm doing the same thing, but this time I'm going to be using completing the square to be able to find this equation of my ellipse. So I'm going to start by getting my x's together, and I can't complete this square until I don't have anything in front of x. So I'm going to go ahead and take the 5 off, and that's going to give me x squared minus 4x, and I'm going to leave a little space right there. And then I'm going to take the 2 out from in front of my y squared, so that's going to give me minus 8y and plus something, leave a little space there. And then on the other side, I'm going to go ahead and subtract over this 2, so I'm going to get a negative 2 right there. Alright, so 5 right there, and a 2 over here, and I'm going to complete the square to find the number that's over here. Alright, so bring down my x and bring down my y. And to complete the square, I'm going to take half of my middle term, including the sign right here, so that's going to give me a negative 2. And when I square negative 2, I'm going to get 4, but be careful, I actually added 20 to this side, so I need to add 20 to that side as well. Okay, and then same thing here, I'm going to take half of my middle term, that gives me negative 4, and negative 4 squared gives me 16, but I actually added 32 to that side, so I'm going to add 32 over here as well. Alright, so just let me check my math here real quick. And I'm going to do negative 2 plus 20 plus 32 does give me 50 over here. Now we said in our equation right here that this is equal to 1. And so in order to make this equal to 1, I'm going to divide through by my 50. And I'm going to do that to every single little piece, all 3 fractions there. Alright, so this first one's going to give me x minus 2 squared over 10. I'm going to let my 5 and my 50 reduce. And this one's going to give me x minus 4 squared over 25. And that's going to all be equal to 1. Okay, let's see here. That was 43. Let's jump over here to 44. So 44, I'm going to do a similar thing, but this time with a hyperbola. With a hyperbola, what you want to be careful of is the negative sign that's right there. So my standard form for my hyperbola, and I'm going to write it with y first because I'm working with a positive y value, is going to be this. And with a hyperbola, a is always first. A is always first on a hyperbola. So that's the standard form of my hyperbola that I'm looking for here. So let me start by getting my y's together. Let's see, I'm going to move my 14y up here and leave a little space. And then I'm going to take a negative 64 off of my x squared, which is now going to give me a plus 2x. So watch out for your sign change there. And leave a little space. And then I'm going to move my 79 over to the other side. Alright, so this one will give me y. I keep my minus 64 over here on my x just for a few minutes. And so when I complete the square, I'm going to take half of my middle term, including the sign. So that's going to give me minus 7. And negative 7 squared gives me 49. So I'm going to add 49 over here. Okay, nothing in front that time to multiply by. And then on this one, half of my middle term is going to give me plus 1. And 1 squared is going to give me 1, but really I subtracted 64. So I need to subtract 64 over there as well. Okay, and again, I'm just going to do my math over here real quick. So 79 plus 49 minus 64 still gives me 64 over there on that side. And again, I'd like for it to be equal to 1. So I'm going to divide by 64, and divide by 64, and divide by 64. So my answer is going to be y minus 7 squared divided by 64 minus, and then my 64s are going to cancel out on this one, but I'm going to go ahead and use 1 as a placeholder down there, and then a hyperbola is always equal to 1. Okay, and then on my last one of these, where I'm changing into a different form, it says a transformational form. That's still going to be just the standard form of this one. Let's work with one that is a parabola. So on this one, I'm going to get my x squared over here on this side. So I'm going to take out a negative 2. That's going to give me a plus 20x on the inside right there. And then I'm going to move anything that doesn't have an x over to the other side, like that. So it'll change the signs of both of those. Okay, so I'm going to keep my negative 2 that's in front right there for a minute, and I'm going to have x. I'm going to complete the square with that, so half of my middle term, including the sign, is going to give me plus 10, and 10 squared gives me 100, and so really on this one, again, I subtracted 200, so minus 200 over here. All right, so that's going to give me negative y, and then over here now I have just plus 6. Okay, so just to make it a little bit prettier, I'm going to divide over by my negative 2, so I'm going to get that on one side by itself, and when I divide by my negative 2, I'm going to get 1/2 y. My negative divided by a negative will be a positive, and then I'm going to subtract 3. And then again, just to put it in the standard form, I didn't write down standard form for this one. Let me do that really quick. Y minus k over there. Okay, so just to get in that standard form, I'm going to take out the 1/2 there. Alright, so that's going to give me plus 10 squared over on that side. And I'm going to take out a 1/2, which is going to give me y minus, and when I divide that by 1/2, that's going to give me a 6 inside there. So think about if you were to distribute back in, 1/2 times 6 would give you this 3 back right here. Okay, now let's get into some graphing. So the first thing I need to know is what kind of shape this thing is. This one's going to be a circle since I have the x minus h squared. Let me write this equation down in here again. Plus y minus k squared is equal to r squared. So first it asks me to identify the center. And the center on this one is going to be 3, -1. Again, opposite sign from what's inside there for h and k. So 3, -1 is right here. And then if I know my radius squared is 16, then I know my radius is going to be 4. I'm going to count 4 in all directions. 1, 2, 3, 4. And 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 that'll give me a nice circle shape there. All right, on 47, I'm graphing a hyperbola. I know it's a hyperbola because I have the 2 squared terms and I've got that minus sign in between. So let me start again with my center point. So x comes from x, opposite sign, and y comes from y. There isn't anything with y, so I'm just going to call that 0. So -1, 0 right there. All right, then I'm going to go A. So A in this case is going to be 5. I'm going to go A and up and down because y is first. So with y being first, I know my hyperbola are going to look something like that. If x was first, I'd be left and right. So I'm going to go 5 up and down to find my vertices. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And so I'm going to have vertices on this one at -1, 5 and -1, -5. Okay, I also like to find my foci on this one, so I'm going to do c squared equals a squared plus b squared. And so in this case, c squared is equal to 25 plus 10. So c is going to be the square root of 35, which is going to be just a little bit less than 6. I'm going to do that in the same direction I did my vertices, so that's going to be here and here. Just a little bit less than 6. And so that's going to be at -1 and plus and minus the square root of 35. So because I went up and down with that, I'm going to add and subtract to my y value of 0. So 0 plus and minus the square root of 35. Okay, the next thing I want is my asymptote equation for my slope. So in this case, because y is first, I'm going to have that be a over b. All right, so a we already know is 5, and b is going to be kind of funny on this one. It's going to be the square root of 10. That's all right, so let's hear square root of 10 is going to be a little bit more than 3. So I'm going to go up 5 and over 1, 2, 3, and a little bit more. And down 5 and over 1, 2, 3, and a little bit more. And this way, 1, 2, 3, and a little bit more. And this way, 1, 2, 3, and a little bit more. I'll make that box that includes our vertices there. And so that's going to be my asymptote slope, which will give me those lines. And to write my asymptote equation, I'm going to use y from here. Don't use the squared because it's going to be a line, is equal to plus and minus my slope. I'm going to leave it like that. With x from here, again, don't use the squared because it's just the equation of a line. All right, and I'm going to go from my vertices out towards my asymptotes. And same thing here and here. Always draw from your vertices, not from your foci. Watch out for that. Okay, on 48, I'm drawing a parabola. I know it's a parabola because I just have the one squared term. I'm more accustomed to looking at a parabola this way, so I'm going to switch my sides first and look at it like that. Okay, so I know if x is squared, I've got just kind of a traditional parabola. So on this one, since y is squared, I know that it's either going to open right or left, and because this is negative, I know it's going to be going to the left. So I know my parabola is going to look something kind of like that. Okay, on a parabola, we call the center point the vertex. So h, x from x, y from y, opposite sign. So that's going to be at -3, -5. 1, 2, 3, 4, 5. Okay, to know how far we're going to open, I'm going to go and say that 4p is equal to -4. So p is equal to -1. I got that -4 right there. So I'm going to open to the left and go find my focus right there. So my focus is going to be at -4, -5. Next, we find the directrix, and the directrix is the same distance, so 1, but in the opposite direction. So I went to the left one to find my focus. I'm going to go to the right one to find my directrix. So that would be here, and that's a dashed line, kind of looks like an asymptote. And so that's going to be at x equals -2. And then my axis of symmetry, I'm going to call that my A of S, is going to connect my vertex and my focus. So that's going to be right here. And so that's going to be at y equals -5. Okay, and the last thing I need just to know how far to open this thing is going to be my focal width. That's going to be the absolute value of 2p. So in this case, with p being -1, that's just going to be 2. So I'm going to go 2 from my focus and 2 from my focus. And there's my parabola. Okay. Okay, the last one for this video is 49. On 49, we're graphing an ellipse. Again, I know it's an ellipse because I have the two squared terms with different numbers under here and the plus sign in between. That's how I know that it's an ellipse. So let's start with our center point again. So x from x and y from y, opposite signs. So 2, -2. On this one, A is the bigger one. It happens to also be the first one. And so I'm going to go the number that's underneath x, left and right. So I'm going to go left and right 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And the number that's underneath y is what I'm going to do up and down. So I'm going to go up 4. 1, 2, 3, 4. And down 1, 2, 3, 4. So this one, our A and our B are kind of close together, so it's going to make it look a little more circular. It's got kind of an egg shape to it. Alright, so for my vertices, I went left and right 5, so that's going to put me at 7, -2, and -3, -2. And then for my co-vertices, I'm going to be at 2, and I went up and down 4, so 2, 2, and 2, -6. So just where I put all 4 of those points. All right, with an ellipse, I'm going to do c squared equals a squared minus b squared. So c squared is equal to 25 minus 16. So c squared is equal to 9, and c is equal to 3. That's kind of nice. This one came out to be a nice, neat number. I'm going to do that along my major axis, so my bigger one, just by a little bit, was left and right. So I'm going to go left 1, 2, 3, and be over here at 5, -2. And I'm going to go 3, 1, 2, 3 this direction, and be at -1, -2. And then the last thing they may ask you about is the eccentricity. And to find eccentricity, I'm just going to take my C value and put it over my A value. And so in this case, C was 3 and A was 5.